Okay, so taking a look at this, determine whether you can construct many, one, or no triangles with each description. Okay, so an isosceles triangle with side lengths of 3 centimeters, 8 centimeters, and 8 centimeters. Okay, my gut tells me that it's only going to be one triangle. Okay, and that's because when we're looking at this, we have given side lengths, right? We have 3 centimeters. Okay, off of this 3 centimeter side, we have one that's 8 centimeters, and we have to connect back to the other side of this triangle, so we have another 8 centimeter side here. Okay, now because this is an isosceles triangle, okay, these angles have to be the same, these side lengths have to be the same, and we're just left with this other angle right here. Well, that doesn't give us enough to be able to change or manipulate. I can't bend the triangle over without changing the lengths of these two sides. So this is going to be a pretty fixed, set in stone one. Okay, a right triangle with two congruent sides. Okay, I'm going to say that this one's probably going to be many triangles. Okay, so if we're looking at a right triangle, okay, we have a right triangle with a right angle, and these two sides are congruent. Now, this side could be 1 centimeter, and this side could be 1 centimeter. Or this side could be 2 centimeters, and this side could be 2 centimeters. Okay, but that gives us infinitely many triangles that we can create as we just kind of extend these sides out farther by the same amount. Okay, and we end up with lots and lots and lots of triangles that follow this same exact formula, right? We have this whole many triangles can be right triangles with two congruent sides. Okay, now a scalene triangle with side lengths of 2, 11, and 14. Okay, this is where I'm thinking we're probably going to hit no triangles, and it might just be that way because I see that we have two of the other ones. Okay, but let's take a look at this too. Now, we know that our longest side here has to be 14 centimeters long. Okay, so our longest side has to be 14 centimeters long. Okay, now our two short sides are 2 and 11. Okay, when we're looking at this, we have on this side, okay, a thing that is 2 centimeters long, and on the other side, okay, we have a thing that is 11 centimeters long. Okay, now when we're looking at this 2 centimeter side, we don't have an angle, so it can be really spinning at like any angle here, right? It could be at a 90-degree angle, or it could be at a 1-degree angle, right? So what we have is a kind of circle of all the different endpoints possible for this, okay? And then looking at our other one, we have a circle, and that's a really bad circle, but it kind of illustrates the point, okay? Of all the different possible endpoints that it could possibly have. Okay. Now the reason I kind of drew it like this is because I want us to see that even if we were to lay this side flat, right, and that's probably better, we have 11 centimeters back this way, and even if we were to lay the other one, this blue one right here, we only go 2 centimeters the other direction, okay, because our longest side is 14 centimeters long, we end up with this 1 centimeter gap in between our two sides, right? Because 2 and 11 is only 13. There's not enough to be able to go all the way back across, okay? So we wouldn't ever be able to close out our triangle here. So we need to make sure we're being careful when we're doing questions like this. Think through the situation, try and see if we can make triangles using that information, okay? Let's check our answers. Oh, I guess we should probably select our answers first. And we're good.